Today's lesson is looking at time series graphs. So time series graphs are a line graph with a series of points joined together with straight lines. And they involve having time on the x-axis. So an example is a patient's temperature was recorded every 2 hours after being given medication. So here is a line time series graph of their temperature. So each point records, so their initial temperature is at 0 with 41.5, 41.2. Then after 2 hours of receiving the medication, they get to 41.1. Then we end up with, after 4 hours, we get 39.5. After 6 hours, we're down to 38. And we end up, after 8 hours, 37.5. Then after 10 hours, 37.1. And after 12 hours, we end up with 37.05. So obviously, time series graphs show us a progression over time. So what are the key features that we need to make sure we include? So first of all, we've got a clear title that describes what we're measuring or showing. The other one is we've got axes labels. Each axis is clear. It has a clear starting point, and that each interval is the same amount. These are going up in 1 on the y-axis. On the x-axis, we're going up in 2s. The points are plotted as coordinates, so they should match up with the correct values on each of the measurements. You'll notice that they've used x's here. You could use dots, crosses, dots, squares, whatever. And that the points are joined by straight lines. Also with time series graphs, you can add another set, which is easy to do. And what does this line represent? That's right, it's the normal body temperature. So we can see in this situation that the person who was getting measured was quite unwell, and it took them 12 hours to recover to their normal body temperature. And in fact, after 6 hours, they had reduced to only a 1 degree above, and even after 2 hours, they hadn't changed that much at all. So maybe it took 2 hours for the medication to start working. So we can gather information over time of the same subject. So because temperature is always on the x-axis, it's called a time series graph. Now the key thing we use time series graphs is to identify trends over time, especially when there's natural fluctuations or changes that happen. So here we've got an example after installing a loft, which is just your attic or above your ceiling and below your roof, or the gap there, some wall insulation. A householder wants to review their gas bills to see if they've saved any money. So what you can do, and what they did, was they put their gas bill together. So the first thing we need to think about is why the labeling and how it works. So the first thing, why is there a first, second, and third and fourth? Okay, and we can clearly see that from the title, what's going on. And that we've got the year, we've got the quarter. So obviously 4 quarters in a year. So the utility or the gas, electric, water bills are sent out every 3 months, which is a quarter of a year. So why is there so much fluctuation in the graph? Is there a pattern? And also, how do we know that this data was not from New Zealand? So the key reason, or the way we can work out that this wasn't a New Zealand, first of all, very few of us have a gas bill. However, that's becoming more prevalent now with people having gas bottles and things like that. The main reason we can tell that this isn't in New Zealand is that the lowest gas bill came in the third quarter. So if we think about our months, the first quarter would be January, February, March. The second quarter would be April, May, June. Then we have July, August, September, and then we have October, November, December. So it doesn't actually make sense in the New Zealand climate that the cheapest gas bill, which we use for heating, would be in the July, August, September. But actually those are the summer months of the Northern Hemisphere. The other thing we should notice is that because of the changes of months, that's why it goes down. So our peaks are happening in winter and our troughs are happening in summer. So that's a pattern that you would expect to repeat. So the big question is trying to work out whether he's actually made any savings. So when you have changes like that, it's much easier to compare the same points. So if we're saying that that's winter and summer, you can see that there's a slight increase. There's a slight increase in the cost. So that would actually suggest that he hasn't saved any money from the insulation. And it's this key trend over a long period that avoids looking at these smaller patterns. So if we have a look at passengers on international flights between 2002 and 2006, you can see at times it goes up, times it goes down, but generally over the long run, there's an increase all the way through. We call this the trend line, and we usually look at the start and the finish of a period we're interested in. And the overall trend in this scenario is that it's increasing. Short-term features which come up, we've kind of touched on this before with the gas bill example. Here we've got heater sales. We can see that there's a peak there and a trough. So this is a New Zealand example because we have a peak in January, a trough in January and a peak in July. And that's a pattern that is repeated onwards. Now, the great thing about having a pattern like this, if we wanted to say what the overall trend was, we could say that between January 2000 and January 2005, there's an overall increase. And then the great thing about a seasonal pattern is that we can use that to predict what the next year is going to look like. That we could predict that it would look something along the lines of that. Other important features that we can notice if we look at spikes and outliers. So here's some passengers in international flights between 1998 and 2003. We have this massive trough. That's not a repeating pattern. We can kind of try and think for reasons why that is. And obviously looking at the dates, we can see that that's around the time of 9/11 or their September 11th attacks when they cancelled a lot of flights. But what we should be able to see from the overall trend is that it recovered back to its normal pattern. That carried on there. So other things that are interesting looking at spikes and outliers. Here's an example of the NASDAQ stock exchange. So just a quick explanation. The NASDAQ is a measure of the prices of technology stocks in America. So things like Apple, Google, websites, Amazon, things like that are measured on the NASDAQ index. And this is its time series graph for its the length that it existed, which started in 1980, or the 9th of May 1980. So what you can see is that over time, that the overall trend is that it's increased between then and now. However, there have been times when we've had large peaks, a trough, and obviously the current one looking at the effect of the coronavirus. So the big thing, just to drill down into this information a bit more, the first big peak, that is actually something that came about at around 2000, looking at the dot-com boom. So around this time was when the internet started getting used for commerce or on a large scale. There were a lot of dot-com companies. You could Pets R Us, role-playing games R Us would open, and all these other beautyproducts.com would open. And lots of people opened all these dot-coms, and because they were making money, everyone invested in them. So we ended up with this bubble where they would increase. Suddenly, when we got to the top of the bubble, everybody realised that a lot of these businesses didn't have any extra cash, couldn't actually trade, and aren't actually making any money. So everybody then sold those stocks again there, and it recovered to about what it should have been had we carried it on there. So that was about where it was. So this trough was the global financial crisis that was around 2009, which caused a lot of problems for a long period of time. And this drop here is for the GFS, and this one is obviously for COVID. So while obviously the current situation we're in with COVID-19 isn't great, you'll notice that this point here, if I measure across there, it's a lot better than it was, say, 20 years ago. So it's gone from about 2,000 to about 7,000 in 20 years. And it's an important thing to note about investments and things like that as well. Okay, so I'm going to look at a series of time series graphs where there's a couple of questions there which I want you to answer, so you might want to get some paper beside you and pause the video, and then we'll take a look. So pause the video, get some paper to write on, have a look at the questions and see how you go about answering them. Okay, well done giving that a go. So the key thing that we need to look at is the first question here, which talks about, look at the time series graph between which 2 years was the greatest increase. So I think the easiest thing to do is looking for increases. Increases on time series graphs are shown by how steep the line is. So the bigger the increase, the larger the gradient, or the more steep the line is. So I would say certainly 1 year was between 2007 and 2008, which refers to those values on the table. The next one that's the biggest increase was looking at 2005 and 2006. Okay, so the next question we've got, you can pause your video and answer them. So find 2 observations about the trend on the graph above, and secondly, using the data from the table, drawing your own time series graph. So two observations we can get from this graph is obviously that the black line, which is the child mortality of Bangladesh, is decreasing, as well as the UK one. However, the Bangladesh values are much higher, but they're decreasing at the higher rate, and the UK ones are decreasing at a slower rate. When you involve two time series graphs, we can get quite a lot of information. So here we've got items stolen and burglaries in England and Wales. So they're either taking CDs, tapes, videos, DVDs, or computer equipment. So pause the video, find two observations about the trend shown. So the key observations when you have two lines together is that where they intersect is really important because both lines are the same. So that's the point where people were stealing the same number of computer and PC equipment as CDs, tapes, videos, and DVDs. So before that point, it meant that more tapes, CDs, videos, DVDs were being taken. From that point on, it means the computers. So in other words, around 2005 or just before 2005, computer equipment became more desirable or worth more than CDs, tapes, and videos. So it's an interesting way to measure that point at which it happened. So there's a task for you to complete on the OneNote lesson page. Complete that now.